Hello friends, welcome to Learn Easy. In this session, we will discuss about the fundamental theorem of arithmetic, composite numbers, and we will do some sums relating to this theorem of arithmetic and composite numbers. Let us start. Every composite number or integer greater than 1 can be written or factorized as the product of prime factors, and this factorization is unique. Let me explain it with some examples. Suppose 54. Factors are 2 into 3 into 3 into 3 is equal to 2 into 3 to the power cube. So this 54 is factor of prime numbers 2 and 3, and this is unique for 54. Another example, so here we can write the factors of 32760 as 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13. 2 cube into 3 square into 5 into 7 into 13. These all are prime numbers 2, 3, 5, 7, 13. So 32760 is a product of prime factors which contain 2, 3, 5, 7, 13. Now, the composite numbers or integer greater than 1. So what is composite number? Numbers which are not prime and which is having factors other than 1 and itself. So here I can add every composite number can be written as product of 2 or more prime numbers. Another 4 is the smallest prime, 4 is the smallest composite number. Four means 2 into 2. Also, the numbers 0 and 1 are neither prime nor composite numbers. Check whether 6 to the power n can end with digit 0 for any natural number n. We know any natural number ends with 0 is divisible by 5. Now 6 to the power n is equal to 3 into 2 to the power n. Therefore, prime factorization of 6 to the power n is 2 and 3. Theorem of arithmetic guarantees that there is no other prime in this factorization. Therefore, there is no natural number n for which 6 to the power n ends with digit 0. We have to make clear that to prove whether a number is rational or irrational, we have to assume first the number is rational. Then we have to prove our assumption is correct or contradictory. This will be helpful to solve the subsequent problems. The problem is prove that root 3 is irrational. So how we will progress? At first, let us assume that root 3 is rational. When it is rational, so root 3 is equal to a by b, where a and b are co-prime and b is not equal to 0. Co-prime means a and b will not have any common factor other than 1. From here, root 3b is equal to a, squaring both sides, 3b square is equal to a square, or it can be written as a square is equal to 3b square. Let it be equation number 1. A square is equal to 3b square. This implies that a square is divisible by 3. When a square is divisible by 3, then a is also divisible by 3. Let a is equal to 3k, then a square is equal to 9k square is equal to 3 into 3k square. Let it be named as equation number 2. So from equation 1 and 2, left hand side is a square, so we can write three b square is equal to 3 into 3k square. From here, b square is equal to 3k square. Now b square is equal to 3k square. This implies that b square is divisible by 3. When b square is divisible by 3, b is also divisible by 3. This means that a and b Both are divisible by 3. Here A is divisible by 3, B is divisible by 3. That is, A and B have common factor C. This is a contradiction of our assumption that A and B are co-prime Co-prime means they will not have any common factor. When our assumption is being contradicted, so our assumption is not correct. Therefore, we can conclude that root 3, our assumption was root 3 is rational. So we can conclude that root 3 is irrational number. That's all.